Nested conditionals, or when one condition leads to another decision, which leads to maybe another decision to make. Visually, imagine you've already made the decision of going through one door, so one if statement was true. But once you've gone through one of the ifs, maybe you have another decision to make. In this case, you might need multiple if statements. This is a frequent question that we get every semester. Can I put an if statement within another if statement? Is that possible? Of course. If you remember, when I introduced if statements, I was talking about the keywords if, else, and end. When I introduced it, I said we could have 1 line, 2 lines, or 1,000,000 lines. Well, we could very well have another brand new if statement. And that is called nesting, to fit an object inside a larger one. So this little if statement on the right here fits within the if, else if part of the first one. But it doesn't just stop here. Between the else if and the else, nothing stops you from having another if statement. And within that if statement, between the else and the end, for example, you could have another if statement. These 3 if statements are nested. They are within a bigger if statement. There is no limit to how many if statements you can have. It really depends on the logic and the complexity of the problem you're trying to solve. To make it work, since there are so many keywords to think about, place them properly. Indent properly at all times. Control AI is your biggest friend when you have to do these nested statements. Good habits from some programmers are: type the if and the end immediately, then complete the inside part. Whether you need an else if or an else, maybe not, but then go back in time and fill it in. That way you won't forget the END. Other programmers choose to comment each end. So if one end is for a particular variable, the END will have an immediate comment saying this goes with the if of whatever. We'll see how that goes. We're going to look at an example with beams. Now keep in mind that this example will be a little more challenging than the other ones we've seen, since we've got to make decision after decision. A beam, as you can see on the pictures, can be either attached on one end or attached at both ends. We are to consider 3 possible setups. One, where there's a concentrated load P at a free end, just like the stick figure right here. Or a concentrated load P at any point, so imagine this stick figure anywhere. Or we have a car idea on a beam that is supported at both ends. Regardless of the setup, we should be able to calculate the slope at the end, the deflection at any distance x of the beam, so how much of a deformation we get from the load being in a specific position, and the maximum deflection. So regardless of where we are, we want to know where the maximum deformation is. There's a lot of applications for these, especially in civil engineering, any kind of transportation mode, whether it's a train, a car, an airplane, or even a simple light fixture on the street. These are very common ideas. The equations is of course well known. Whether we have the 3 options, we have a lot of equations. The slope at free end is rather straightforward. The deflection, though, you can notice that for both cases at the bottom, we have 2 different options. Depending on the location of x, where do you want to know the deflection? Is it before the load or after the load? The load makes a big difference. So we have to make a decision right there. For the maximum deflection, it's straightforward. We only have 1 equation. In addition, in the last case, we're also able to calculate the location of the maximum deflection. On the other 2 options, it's obvious that it's at the very end. Now when we start coding, of course, how to approach the problem is always the difficulty. Where should I start coding? What should I start coding? There's so many decisions to make. What should I do first? Always start with your very big algorithm. We're going to prompt the user the type of beam. That's of course our first decision. and then we'll calculate and display everything. Then you have to make a little bit of more of an option. Step number 1, always go through your steps. What givens are needed right here? Which ones are common to all the beams? Well, the load P, the length of the beam, and the X position. We can calculate the deflection at any X location. So right there are 3 inputs that we need regardless of the beams. So that's going to move up in the code. Just like asking for the type of beam, right there we'll ask even the length, the P, and the X. Then you push a little further. What additional givens are specific to each problem? Look at problem number 2 and 3. We need that A length. We don't need it for beam number 1. So we can't put it at the very top of our code. Just in case I ask for type of beam 1, I shouldn't be asking what's A. I don't have an A. So that's a decision of where you locate your lines within your if statements. After that, plan the if statements. Where will you have to make a decision? Well, the first decision we have to make is which type of beam. So right there is our first if statement. That's our main priority. Before I can choose the equations, I have to make a decision, type 1, 2, or 3. If I choose type 1, the equations are straightforward. I have no decision to make. If I choose type 2, however, the theta and the deflection are straightforward. But for the deflection at any point, I gotta make a decision. Am I on the left side of the load, or am I on the right side of the load? So right there, because I have to make a decision, I will need an if statement. Type number 3 is very similar. Calculating the angle and the maximum deflection is straightforward, one equation. But once again, for the deflection any point on the beam, any X location, I have to make a decision. Am I before the load or after the load? You can immediately see that we have 3 if statements. So in MATLAB, the easy part has been done. You may have noticed 2 different variables, E and I, that were also in the equations. This is all due to the material the beam is made of, so I've gone ahead and already coded the values. I've prompted for the length of the beam, the load, X, and the type of beam needed. Notice I did not choose length. Length is an actual keyword in MATLAB, just like sine, cosine, and so on. You will learn those as you go, but I know that length is already a keyword, so I don't want to use keywords. Just like the previous example, I've gone ahead and cheated and typed all my equations. They will need to be coded at one point. There is no way around that. But the idea now is to tell MATLAB to skip pieces. So this is for type of beam number 1, type of beam number 2, type of beam number 3. Notice how I've used the same variable name everywhere. The deflection at a specific location X, I didn't create 5 different variables. MATLAB is only going to execute one of those. So I don't need to bother coming up with 5 different variable names. There is only one that's going to run. For theta, same thing for the first 2. For the third option, I do have 2 different thetas, so I did make a differentiation. The deflection maximum, identical. Whether it's option 1, 2, or 3, MATLAB will only see one of those lines. You'll see that this makes it simpler later on to print the result. So I'll go ahead and write the first decisions that I have to make, which is what type of beam it was. If it was type 1, I want these equations. What's the keyword for type 2? I cannot go with an else alone, since I have to decide whether it's option 2 or 3. I know it's not type 1 because I'm on the else, but is it type 2 or is it type 3? So I have to go with else if. How about the keyword here? Can there be another option, assuming that the user does everything correctly and follows direction? I've either entered a 1, 2, or a 3. If I'm already on the else, it means by default that it was not type 1, this is false, and it was not type 2, this is also false. So if it's not 1 and it's not 2, what else can it be? It has to be a 3. So I don't put else if. I don't have another condition to check. I only have 3 doors possible. I've eliminated door 1 and 2. Well, it has to be door 3. Alright, and the final keyword is END. Control AI fixes the indent. So I've made my biggest decision, and that I'm done with it. That's the idea of coding by parts. You code the biggest ideas first, and then you move on and change it. Of course, everything's wrong inside. Right now, if I do door number 2, I get all of these results. Completely useless. But now I can go in and modify piece by piece. If it's type number 2, there was, if you remember, one additional input we needed. I can only put it here. If I put it above, then it will be asked every single time. And that's not right. I want to decide when I need the A variable. And I need it in type 2 and type 3. Enter where load is in meters from left. I will also need it for type 3, so I'm going to copy paste immediately. So once I have the distance A, I can immediately plug in and get the theta location. But however, now I got to make a decision. Should MATLAB do this equation or this equation? If you remember in the PowerPoint, the first one only happens if x is between 0 and A. Now, assuming once again that the user didn't put any invalid data, we'll see how to handle that later, then if, how would you write that? Well, our variable x, I've kept it simple, is actually named x. So if x is less than the distance A, I want to execute the first one. What's the line that goes here? If I do an else if, that means I have multiple other options. But x is either less than distance A or it's not. So once again, I choose my default, which means that x is greater than or equal. Don't forget the equal part to distance A. And the END goes right there. It doesn't go all the way to the end here. Where do you want MATLAB to skip if it doesn't do this equation, or if it does, is right here, and continue to calculate the maximum deflection. So once again, indent properly and it'll help you figure out where MATLAB jumps to. If the distance x is less than A, then MATLAB will use this equation and immediately skip to the END here and continue on with its life. So it'll calculate the maximum deflection here. What line will it skip from to here? MATLAB will skip to line 44 and continue with the code. Right now we don't have anything, but we definitely will have fprintfs. So that's how MATLAB works. Now MATLAB will only execute one of these two options. Same thing for option 3. We need distance A, we calculate distance B, theta 1, theta 2, but now we got to make a decision. If you want, decide which side of P we're on. So same idea, what will be here? It's actually identical to above. If x is less than distance A, so on the left side, if you want, and then else on right side. Where should the END go? Should it be between line 45, 46, 46, 47, or 47, 48? Well, where do you want MATLAB to skip to? If the distance is less than distance A, MATLAB will execute this line. And where do you want MATLAB to go from here? Do you want MATLAB to skip to the very end, or do you want MATLAB to go and continue some other equation? You definitely want the maximum deflection and the maximum location to be calculated. So you want MATLAB to skip right before this line. And there you go. You have made nested statements. This if statement is nested within that else if. The other if statement that's nested is this one. Now, as far as displaying everything, we've made all the variable names identical, so you can see how it simplifies it here. What's the one variable that has to be displayed in all cases? Unfortunately, theta is only in type 1 and 2. Notice it doesn't appear in type 3, so this one we'll have to do separately. But how about this one? Well, type 1 it exists, type 2 it exists, and type 3 it exists. So regardless of what type, I will have to print it. Deflection at the x location is Remember, 4 minutes ago I was saying don't create a variable name for each of the cases. This makes it simpler. Had I have y deflection x1, y deflection x2, 3, 4, 5, then I wouldn't be able to write a single fprintf at the bottom. I'd have to write a single fprintf here and here, one for each variable. The other one that I have everywhere is y deflection max. It appears 1, it appears 2, and it appears above. So that's the same thing. I can also put it there. Deflection maximum is there. The blue highlight does help. Theta, we said, couldn't be done that way because for part 3 we don't have a theta. So unfortunately on this one we will have to do it every single case. The only variable we didn't print was this one. Question for you, where should I put the fprintf? Let's start with the wrong answer. If we put it anywhere below, that means that regardless of type of beam we pick, 1, 2, or 3, it will execute. But if it's type 1 or 2, notice there's no blue. That variable has never been created because we don't have an equation for that. So we can't put it outside of the if statement. We have to put it within type 3. So the only location it can go is right underneath it. There. And that basically concludes our code. Now notice, remember, you can't really see everything. If the if statement starts here, it ends on line 53 with the END. The else if is attached to that if. But you can keep track of everything if you build piece by piece. I am missing a couple comments, so I will take the time to add my comments now. And there you have it. Lengthy code, but you will notice that every time you have decisions after decisions after decision, it's not unusual to have a lot of nested statements. The indentation tells you how many decisions you have to make. The first if is your first decision. The second if is your second decisions. The key points on approaching these problems, they are more challenging, I agree, is that it requires nested ifs. A lot of decisions, a lot of if statements. Find each condition. In our case, we had to decide what type of beam and where we were with respect to the load. Find when you have to make a decision. Make a drawing, make a diagram. Maybe visually you can draw the code first before you code it. Build each if one at a time, especially if lengthy, since you're going to have to scroll through many lines of code. We built the first one, which was type 1, type 2, type 3, and immediately I had the END. And then we went in and we built in every other little one, but we kept it little piece at a time. Remember that every if requires the END keyword, and that will tell MATLAB where to skip to. That's the important point. Else is always last and requires no condition on its line, and I've used it for every single default that I had to. Review your code at the end. Find pieces that maybe are common to all conditions, and then simplify. Because I named my variables the same everywhere, I was able to pull out the fprintf statements.